organization point of view. So addressing ISP. So how ISP are taking care of the IP address or for providing to the smaller organizations. Okay, suppose considering an organization which have procured a ACE number, and that organization has taken the ISP lease line from any one of the service provider, how that addressing is done from that ISP. So basically, first is the like ISP need to reserve the address space for its network. So it also the has to allocate the network blocks or address blocks to its customer for point-to-point connectivity, for establishing BGP neighborship, we can say. And also ISP has to take the growth of that organization into consideration. So if the organization expand or looking at the scalability point of view or expansion point of view, that growth need to be considered, taken into consideration while addressing the address blocks to any of the organization. So BGP basics. Basically, we'll talk about now what is like terminology of the BGP or protocol basics of BGP, how the messages are being exchanged in this BGP protocol, or operation of the BGP, and pairing relationship, like different relationships are there, like eBGP and iBGP, and routes originality. So first we'll go about like terminology. So basically terminology in the neighbor is like the configured BGP pair. So AS number 1 and AS number 2, between both the AS two border routers are the neighbor, are the peer for each other. The neighbor means the configured BGP peer. Then the NLRI or a prefix. So NLRI is the network layer reachability information that need to be given to the BGP pairing, or the reachability information for an IP address or the subnet mask for the routes. Then the router ID is used for BGP neighborship, which is with router ID is like highest IP address configured on that router, or the loopback IP address we can say, which is called in the as a router ID in BGP. Then the route path, like the IP address reachability information which is advertised by the neighbor is the router basically, or the path across that neighbors, between the neighbors we can say. So these are the protocol basics. So AS, here we can see like AS 100, AS 101 and AS 102. There are three different AS, and all these are the border routers. Like A, B, C, D, E are the border routers for intercommunication of the different AS. So basically, the pairing of A to C like is the pairing, BGP pairing to exchange the routes. So the routing protocol here is used between the AS, which is eBGP, and like if you aren't connected outside the AS, then there is not required for BGP to use here. So IGP protocol can be used, like connectivity between these both A and B, which is within AS number. Okay. Or there are, like we'll talk about that later, there are two types of BGP, like iBGP, which can be used within AS, and eBGP, which is used outside the AS. So basically BGP runs over the TCP protocol, which works on the layer 4 reachability. Okay, so BGP runs on the layer 4 over TCP, and also like three-way handshake process is done for making the BGP peer to up. And it is a path vector protocol, and incremental updates are there. Path vector means like if a route has to traverse from AS 100 to AS 102 and the best path is from AS101, for example, then the route from AS100 to AS102, you will see like the path vector is used. Like in that route, you will see AS100 is the first hop, AS101 is the second hop for that specific route, which is learned on AS102. So each AS originate a set of network reachability information. Then the information is being exchanged between BGP peers, between two BGP peers. The NLRI information which is exchanged between BGP peers can be over multiple paths for a given prefix. And suppose there are multiple paths, then out of that two paths, we can pick the best path which is installed in the forwarding table. So there are two types of table, right? Like RIB, which is routing table, and the second is like forwarding table. So routing table is a table which has all information. Suppose I have four service provider links on my router, and the same internet route I have reached from all the four links. Then in my routing table, the route will be installed using all the four links, all the four neighbors. But out of four, only one neighbor will be preferred, which is calculated on the best path. And that route is installed in my IP forwarding table. Okay. So again, the best path can be selected manually as well, using different type of attributes for the routes to travel from one AS to other AS. So we'll speak later how the policies can be applied for, and what are the attributes that can be used for applying the policy for traversing the any type of the route. Okay. So BGP peers. So suppose this is AS100, AS101 and AS102. And the link which is shown here, this link. Okay. So the pairing between A and C are the peers, or we can say the BGP speakers to exchange the route. So this route /24 route is exchanged using the BGP pairs. So the BGP pairs speakers from A to C, which is done here, which is from AS100 to AS101. Those are called as, both are in different AS. So those are called as the external peers. Okay. So same B2E, this B2E and D2E. These are also the external peers, as the peering is done between two different ACE numbers. Okay. So these are called as like external peers. Second, like eBGP peers normally should be directly connected. So same, it is shown in the diagram as well. Like the B router and E router is directly connected using the P2P link, over which we can use the eBGP pairing, which is the external pairing. Second is like internal pairing. So internal pairing like is this is second is like BGP pairs which are like internal pairing. So AS100 has two routers, router A and router B. Okay, router A and router B. But both router have same AS number. So both the pairing between router A and B are called as the internal pairs. Okay, and the requirement is like for internal pairing, there is no required for directly connected routes. For internal pairing, suppose like only the reachability information should be there for both the loopback IP address or the both pairing information. You can say. Those are the internal pairs. So this is how the network layer reachability information is being updated in BGP pairing. Okay, so both the routers has to exchange its route based on the parameters which we have discussed earlier. Like there are different type of attributes. Okay, for exchanging the information, network route information between both the external peers. So the network layer reachability information is basically the reachability information for making the BGP pairing to be up, and it is used basically for advertising the feasible route. Feasible route, which is composed of like network prefix or the mask length of that specific route. So now, these are the types of BGP messages which are exchanged between BGP peers, we can say. So there are four types of BGP messages like open, update, keep alive, or notification. These are the update messages which are continuously exchanged for making the BGP neighborship. So basically, open type of message sets up and establish the BGP adjacency. So the negotiation is done for establishing the BGP pairing in this type of message. So update message is like it advertises or updates the routes. So it for exchanging the routing information. This is the update type of message. Keep alive is to maintain the peering information, we can say, or like it ensures that BGP neighbors are still alive. So notification message is for reporting the error condition of the BGP neighborship. So this BGP. So these are the four types of messages which are basically used for BGP neighborship to be keep in established state. So like we spoke about like IGP protocol and EGP protocol. IGP is basically the dynamic routing protocol which is used within the same AS. So and EGP is the exterior gateway protocol. So now BGP pairing, like there are two type of BGP. First is the IBGP and second is EBGP. So we speak about IBGP. So it is internal BGP. So in the diagram you can see that like to exchange the route within the same AS, this IBGP protocol is used. So in IBGP, basically there is no restriction that neighbors have to be directly connected. And however, like an IBGP pairing will not advertise the prefix it is learned from the IBGP pair to the another IBGP pair. So basically, within the same AS, there is like it is like there are chances for the loop. So there is a loop prevention algorithm which is called as the split horizon rule in IBGP protocol. So basically, in that to avoid the loop in IBGP, so the algorithm which is used is like the an IBGP peer will not advertise the prefix which is learned from the same IBGP peer. Okay, so that information is there in the routing information is there in the route type, for that specific route. So in this way, the loop avoidance is done in IBGP. So in IBGP, like there is this restriction is used to avoid the loop within the same ACE number. Also, like to clarify this, when a route is passed through the eBGP pair, the local ACE number gets added to the prefix in ACE path. So if we receive the same packet back stating our ACE, same ACE, origin ACE we can say, in the ACE path, we know drop in that case. So however, when a route is advertised to the BGP pairing, the local ACE number is not added to the ACE path. So since the peers are same, since the peers are in the same ACE, so to avoid the loops in IBGP, two types of methods are used. One is the full mesh topology, and second is using the route reflectors in IBGP. Okay, so we can use like full mesh topology for IBGP to avoid the loop. So every router will be connected to every router in full mesh topology. And basically full mesh topology is like the routers in the same, each and every router we can say. So for example, if we have n number of routers within the same ACE, then we must have n minus 1 divided by 2 IBGP sessions in the same ACE. So using this, we can avoid the loop. The second method which is used in IBGP to avoid the loop is using the route reflectors. So basically, route reflector is the alternative method full mesh topology scenario. So in this case, IBGP sessions are established with a central point in route reflector. So this central point is called as a route reflector, and the other IBGP routers are called as a route reflector clients. So suppose the router A will act as a route reflector in this case, and other routers will act as a route reflector clients. But in that case, there will be pairing between each router to each router. Okay, in this way we can avoid the loop in IBGP. So anybody have any question about this?
Vinayak, Interjet has asked one question. Please tell about pairing prefix count. So can you answer, please?
Okay, just a second.
They have a message on chat.
Okay. Please tell about pairing prefix count. So basically, like correct me if I'm wrong, if I have understood your question right. So basically, pairing is between two autonomous systems, and to exchange the route, there is a policy, and in that we can exchange n number of routes. So suppose an organization have 100 routes within an organization, and that routes need to be exchanged between the ISP. So he can advertise to that ISP, but that advertisement information should also be there at ISP end. So basically, there is a limitation for accepting the route. 24 route will be accepted. Below /24, no routes will be accepted with the ISP. So this is a limitation for accepting the route from ACE number to your upstream service provider. So is your question answered, or
Yeah, we can move forward.
any other example? So example, you can say like, suppose like the BGP pairing needs to be established between your service provider and organization. Okay, so organization has ACE number 100, and organization has 50 routes, 50 public /24 pools within the organization, and that pools need to be traveled towards the internet. So in that case, BGP pairing is done between the ACE 100 and the upstream service provider. Okay, so for that, minimum /30 pool is used for pairing, and over that /30 pool, which is given by the ISP, and over that pool, the BGP pairing is established. And over that, we can advertise your route or you can accept the route. So BGP pairing prefix count, your question is like, there is no limit for the prefix count in this. Only the limitation is like below /24, none of the pools will be accepted by your upstream service provider. Okay, so we'll move forward. Like external BGP pairing, eBGP, which is called. The external BGP pairing is between two different ACE numbers, which is directly connected, or pairing address is reachable for establishment of this communication. So basically, the difference between eBGP versus IBGP is like both are the routing protocols. Okay, both IBGP and eBGP are terms which are used for the routing protocols, which is called BGP. So in theoretical terms, like the main difference between the two is like eBGP runs between two BGP routers within ACE number, and IBGP, sorry, and eBGP works on two different autonomous systems. So before, like we have discussed the difference, like IBGP is like eBGP has a AD value of 20 and IBGP has AD value of 200. Okay. So basically, in eBGP, a TTL value is set as 1. By default, the TTL value is set as 1, which means the TTL value, which means that the peers are assumed to be directly connected in eBGP. So in this case, like taking one of the example, when the packet crosses one router, then the TTL value becomes 0 in eBGP. Okay, and then the packet will be dropped beyond that. So in cases where the two neighbors are not directly connected, basically. So suppose I need to exchange the information, BGP pairing, and the two neighbors are not directly connected. Then if the packet comes over the router, then the TTL over one router, then the TTL value becomes 0. And beyond that, the packet is dropped. So in that case, the BGP neighborship will not come up. So it is mandatory that it should be directly connected. So in cases where two neighbors, so for example, we can say like pairing with loopback interfaces or pairing when devices are multiple hops away. So if the device are multiple hops away, in that case, the IBGP can be used within the AS number. And in IBGP, the TTL value is 255. Okay, so because of that, it is not mandatory that IBGP peers can be directly connected. Okay, so anybody have any questions?
Hi, this is Muhammad Ali from Stampede. Like you said, if the peers are not directly connected, then you said the eBGP is not possible.
Right.
But it is possible. We can set eBGP multi-hop.
Yes, but it is not it is possible within ACE. So with ISP, it is not possible.
With different AS, we can set eBGP multi-hop 2 or 3. Then TTL will be increased.
But in that I understand that, but that is limited to your within organization. Suppose I have 3 organizations and within the organization, all the routers are in my control. So ISP does not accept the multi-hop configuration for the BGP neighborship.
We are speaking about a theory. We are not about the practical things. So theoretically, it's possible.
Yeah, theoretically it's possible.
I don't know whether they're allowed or not, but I did some implementation with BGP multi-hop.
Yes. Theoretically, it is possible, BGP multi-hop, but it is possible if all the routers are within your scope. But in the internet world,
even ISP can set that. Why not?
There are certain ISPs. There are certain ISPs who provide BGP prefixes from centralized routers.
Yeah.
So those cases they allow multi-hopping. We have done it with Tata and even NKN for internet. This one from NKN, if we want to prefix it, we have to enable multi-hop.
Theoretically, it's possible.
Not theoretically, practically also we have done. This is Satish.
No. What I'm saying is when we're discussing things here, theoretically, do that practically is possible. But if ISP is not allowing, it's different thing.
Yes. In internet, ISP is not allowing for multi-hop kind of thing.
I have one question. Like, can you just give us some detail on configuring multicast or network?
Sorry, can you come again?
Can you give how the multicasting works in BGP?
Sorry, your voice is not clear, audible. Just a second.
Hello, am I audible now?
Yes, very much.
Can you give some details on how to configure multicasting in eBGP?
Again, I think you have dropped only multicast.
Telling that multicasting in eBGP. Hello, Vinay.
Yeah, that is exactly what I was asking.
Hello, Vinay. Are you able to listen my voice? Hello.
The echo is there. Just a second. I'm not able to. Just a second. I will rejoin. Yes. Go on. Hello.
Vinayakji, can you give us like how to configure multicast in eBGP? See, I'll be advertising some some IPs from my different centers. Okay. So I want the packets from the nearest geographical location to reach to the nearest router.
Okay. So basically that is used, like that concept is like anycast routing basically. So anycast routing. So in anycast routing, basically what happens is like, suppose I have three data centers, for example. Okay, so I am serving a service and that service need to be served. Suppose my user is in Bangalore and I have a data center in Bangalore, and that user data needs to be served the locally, which is from Bangalore. So in that case, the anycast routing is used. So for anycast routing, basically it is also needed for GSLV, which is like global server load balancing. So what is done, like the gateway is there on all my data centers and the nearest data center will serve for the nearest user basically. So a lot of the organizations use that in like VPN kind of thing, like for connecting the VPN for that organizations. So that technique is used from a lot of organizations. So that concept is like anycast routing basically, not multicast routing.
Yeah, can you just give some details on that, like how to configure that or what will be the requirements for doing that?
Okay. So basically, GSLB server is used within the same. Suppose I have 3 data centers. Okay, but in all the 3 data centers, same AS number is used in that case. Okay, and from same AS number, I can advertise the same route. Suppose route is there, like external route is there, like 115.124.115.0/24, for example, and the gateway of that application for serving the data for the user is on all the 3 locations. So that GSLB server will take care of that routing from the nearest server, nearest location. So based on the, again, like routing information only. Okay, so it will look upon the AS path again. So AS path attribute is used there, and it has the functionality. GSLB has the functionality to route the packet to the nearest data center, basically.
Okay, basically my requirement will be I should have the same IS number and the same route advertised from all the routers, and
Yes.
then I should have a global load balancer to switch
Right,
to
right.
other.
Same. So basic is like the gateway is same gateway is there on all your locations. Okay, and the nearest location will serve your application.
And
So
for internally, should I use IBGP only or any other routing protocol I can use like OSPF or anything?
any internal routing protocols you can use any other, but for that purpose, your data center should be interconnected for IGP protocol.
Okay.
Using P2P links and or any kind of things for IGP protocol.
Okay.
So there you can use OSPF or IBGP, but again for IBGP you'll have to do the full mesh kind of topology there for maintaining the redundancy. Okay, so there using that you can avoid the loop avoidance kind of thing, or redundancy kind of thing. You can avoid that thing.
We have internally MPLS VPN connectivity among
Yes, that will be fine. Yeah, using internal MPLS connectivity, like you can use OSPF for underlay, you can say, and for overlay you can use IBGP.
Okay.
Only the reachability will be there using OSPF, and overlay will be configured on IBGP.
Okay.
And with the ISP, your service provider, EBGP will be required.
Okay, fine. Thank you, Vinay.
Okay, okay, fine. So where were we? We was talking about the TTL value. So in eBGP, like the TTL value is by default like is 1, and using the multi-hop we can extend it, but within the organization. Most of the ISPs does not allow to use the multi-hop kind of thing. Okay. So any other questions for like eBGP, IBGP difference and all? And eBGP as well, like when the route is advertised to IBGP peering, so in that case, the next hop remains unchanged. So for that, the next hop self command is used for making that next hop remain unchanged for traversing the route. So now we will speak about the BGP updates, like attributes which are used for tuning the BGP. Okay, so I think we'll take a 5-minute break. Is it okay? We'll take a 5-minute break, and then we'll resume it.
Okay. हेलो इस प्रकार जी
Okay. So, any questions for past slides, please?
Hello.
Yeah.
Hello, Vinay. This is Vivek.
Yes.
Actually,
Yes.
I wanted to ask about route reflector.
Okay.
Suppose if we are configuring any router as a route reflector, then suppose any route reflector clients want to talk with another route reflector client, then mediator will be route reflector only, right?
Yeah, yeah. So the update of the routes which are given will be given from route reflector only in route reflector scenario.
Okay, okay. Thanks.
So client will not give the update to another client. Okay. So
Okay.
the mediator like route reflector which is configured there. So only route reflector will give the update to its clients.
Okay. Thanks.
Okay. So the last question from I think from what that multicasting question from was from.
I'm from CDAC. Satish.
Okay, okay. So basically this multicasting. So can you tell me any of the scenario for multicasting? I think it is used within the organizations for enabling the multicast routes, or like MPBGP is used there for multicasting. So what it means, like L3 VPN is configured over the route for exchanging the multicast routes. So any multicast routes are not exchanged within internet routes. The L3 VPN is configured from one router to other router for exchanging the multicast routes. So do you have any scenario for like this?
No. So actually, we want to set up Anycast DNS and CDN network. So actually, my question was
The CDN
about
network. Yeah, yeah, yeah. So our CDN Anycast network is used. Like that was perfect. So anybody have any questions? Okay. So like now we'll talk about the BGP attributes. So which are used for traversing the route, or which are used for giving the route from one AS number to other AS number, or any kind of thing. So basically the first attribute is like AS path attribute. Then we have next stop attribute, local preference, MED value, community, then origin of the route, or aggregator of the route. So these are the attributes used, which are used for the BGP route updates. We'll talk about it. Okay. So AS path attribute. So basically, AS path attribute is one of the most used BGP path attribute by the major service providers. Okay, so in AS path attribute, basically the mechanism which is used is like whenever a route passes within an ACE number, so it adds the number of ACE which is passed. So the ACE path attribute is the list of ACE, we can say, list of ACE numbers that the router traverses. Okay, so you can say it is the sequence of ACE from where the route has been traversed, like the route has been traversed from source to destination, and from source to destination there are 10 ACE numbers, external ACE numbers. So in ACE path for that route, you will get that information in ACE path. So here is the information which is updated in that ACE path. Okay, so for this route, for example, 180.0.0/16, you can see like this is the path attribute from where the route has been traversed from which ACE number. So basically, it is used for identifying the origin of the route, basically. Okay, sequence of the route, or the loop detection is been avoided in the ACE path attribute after applying multiple types of like policies and all. So in ACE path attribute, if the route is received from same ACE, then that route is dropped. Suppose like for 180, for this type of this route, 300 path attribute is like 300, 200 and 100, and again the 300 ACE number gives this route, and it will come in ACE path, but looking at the algorithm for loop detection in eBGP, that packet will be dropped. So in this way, the loop is been avoided in eBGP. The second is like second attribute, like ACE path is the mandatory attribute, and second attribute is like the next stop attribute, we can say, which is basically used for the iBGP protocol or eBGP protocol as well. So basically the BGP next hop attribute is the next hop IP address that is going to be used to reach the certain destination. This is the next hop attribute. And for eBGP, we can say the next hop is always the IP address of the neighbor specified in the neighbor command for eBGP. Okay, so basically the next hop to reach a network, this attribute is used. Usually local network is the next hop in eBGP session. Also IGP should carry a route to the next hops, and it allows the IGP to make the intelligent routing forwarding decision. This next hop attribute. If next hop is reachable, then only that route will be traversed. Otherwise, that route will be dropped at the local level only. Okay. So in this way, you can see here. So router A has this route 160.10.0.0/16, and .1 is the IP for router A, and 2 is the IP for router B. So in this case, you can see like 2.1, like 192.20.2.1 is the next stop for this route in B. Okay, in router B, next stop will be .1 for this route, and path will be the single ACE number. It's in router B. So this is the second attribute which is used for BGP in BGP. Third is like local preference. So basically local preference is the second BGP attribute, is the BGP attribute which is used to choose the exit path for an autonomous system. Okay, so basically it is used within the autonomous system. It is used for the exit path. So using local preference, so basically this BGP preference, local preference has to be set inbound to the routes, which is being received to influence the outbound routing behavior, basically. So higher local preference is preferred, and most of the devices has like 100 is the default value for local preference. So for iBGP, it is mandatory. For eBGP, it is not being used, local preference. So basically, default value is 100 and it is local to ACE. So in this way, this local preference works. Suppose this 160, this route I have received on ACE 400 on router C. Okay, and router C has two paths to go towards this destination route, which is this route. Okay, so first path is router A and second path is router B. But I need to prefer only router B for exiting the traffic to reach this destination, which is 160.10.0.0/16. So in that case, when I set the local preference 800 for the route which comes from router B and 500 for the route which comes from router A. So in your routing table, both routes will be seen, but the forwarding, the preferred path will be router B if you set the local preference. So always for router C, the exiting path for this route, which is 160.10.0.0/16, will be from router B based on the local preference attribute which you have configured on the router. Okay, so cleared about it? So anybody have any questions for like this AS path attribute, next hop attribute, or local preference? No. Okay. So second is like the MED value. So this is the carrying attribute. This is also the carrying attribute for BGP routes. So it is like multi-exit discriminator. This is the MED value. MED value which need to be configured for the specific route for exiting path. So basically this MED value can be used to advertise to your neighbors how they should enter your AS. Okay, so it is a carrying attribute. So basically MED value is exchange between autonomous system, and always the lower MED value is being preferred for the specific route. Okay, so this all attributes can be configured in the policy for export policy or the import policy for the specific BGP neighborship, we can say. So this is the example for MED. So AS200, AS201, and for AS200 to enter to reach this network, which is 192.168.1.0/24, if the MED value we have configured is 2000 and 1000, then in that case, this will be preferred path for AS200 to reach AS201 or both the path. So this is the significance of MED value in eBGP protocol. So basically it conveys the origin of the prefix and like generated using the network statement and all, and that value is being configured on the policy which is used for the BGP neighborship. So the next attribute, BGP attribute, is the community attribute. So what is like BGP community attribute? So basically the BGP community attribute is an optional attribute basically, which is used for eBGP neighborship, or which is used for the routes which are being traversed, and it is transitive attribute, BGP attribute that is recognized and passed to other BGP peers. Okay. So you might see a BGP community as a tag which is attached to the BGP routes, which is exchanged between two BGP peers. So it is an additional tag on that route which is been received if the community value is being configured for any of the route, we can say, or we can configure the community value for the entire routing table for the specific AS number. So if the route, for example, if I have a routing table of internal routing table of like 24 routes, and that routing table I need to traverse over other AS number, and for to identify the origin of that route, the community value is been tagged on my export policy. Okay, so in that case, when the route is traversed from my AS to other AS, then the other AS will receive the route with the additional tag value, which is been assigned as a community value in my origin AS. Okay. And based on the community, we can also tweak some other changes, like using for that community, that will be the like uniform community for my entire routing table, and I can like set all the like local preference and all on that community as well in the policy. So this is how the community value is being tagged for any of the route, and we can also set the local preference value for the specific community value. For the so suppose this is the customer AS and this is service provider AS, and in that case a community value is being set for both the routes. So in the export policy of router A, I have set the community value of 201:110 and community value of 20201:120 for router B. So in that case, like, and local preference is set for that community in other policy, then this path will be the preferred path basically as local value. Sorry, this. Okay, so anybody have any questions for the attributes? Now BGP route selection. BGP route selection basically is done using the best path. So only one path is being preferred as the best path in the routing table, the forwarding table, we can say. So basically the route has to be synchronized with the prefix in route forwarding table. The next hop has to be accessible for making the routes reachability. Then the largest weight, which is local to the router. On this criteria, the best path is being selected by the BGP neighborship. Or if the route has the largest local preference, then that route will be selected as the best path. Or the route is been redistributed locally redistributed, then that path is been selected as the best path. Or shortest AS path is the best path for route selection. Or the lowest origin of that OS of that route, or the lowest MED value, or external or internal, like closest exit from a router is being selected as the best path, or closest next hop reachability. So basically closest next hop reachability is within like IGP metric, we can say, or it has lower router ID or lower IP address of the specific neighbors. On this criteria, basically the BGP route selection, best path route selection is been done. So routing policy. So routing policy also plays, like already we have discussed, like routing policy is also play major role for the routes to traverse from one AS number to AS number, other AS number, or within AS number, we can say. Okay. So routing policy, why it is required basically? So it is required for making the traffic or traversing the route through preferred path. It is within our hand basically. Or inbound, outbound prefix filtering can be done there in routing policy, or to enforce the customer ISP agreements basically. And how it can be done? So ACE path, based route filtering can be done using the filter list command. Okay, and prefix based route filtering can also be done, and the route maps also can be configured for this routing policy. So basically, consider we have a BGP neighborship between ISP and any of the AS number. So for that, two types of policy can be implemented. First is like import policy, and other is like export policy. Import policy is like import policy is like taking what we want, and export is like taking what giving what we serve basically. So these are the significance of both the policy, and on both import as well as export policy, the changes can be done. Like for export policy, the local preference can be set for the preferred path, or for traversing the route from the preferred path. In import policy, the routing table which is being taken from the upstream service provider, that routing table we can change the route type in the using the policy. Like we can tag the community value, or we can tag the local preference value. Suppose I have taken the entire routing table from all my 4 upstream ISP. Okay, suppose I have 4 upstream ISP service provider in my data center, and I have taken all the routing table, all internet routing table of 9 lakh route from all 4 ISP. Okay, so out of that, the best path will be preferred. So that we can change anyways, like the incoming from Tata, I will take, like it will be the preferred path for me using the local preference, highest local preference value, and then the other will be my passive value. Or you can also balance the traffic based on the best path. Like suppose one destination route, I have taken the entire routing table in my routing policy, but for a specific by using the default local preference and all the default attributes, you can say. So for my destination, it will take the best path. Suppose for my destination route, specific route, the best path is from Airtel. So that traffic will always travel from Airtel. So in that case, the balancing is done between all the ISP or upstream service provider links for the traffic. So in this way, this routing policy can be configured in the for eBGP peers or BGP pairings, we can say. There is one question, I guess. If we have 3 ISP, each /24, I think there is one question from Muhammad. If we have 3 ISP, each /24 IP pool announced in 3 ISP later with to pairing. Okay, got your question. So basically your question is like, if we have 3 upstream service provider and my route I have given to that upstream service announced to that upstream service provider, and we have taken the peering from the internet exchange service, we can say, right? And we want to do the Google and Amazon go through peering, and rest of the traffic will go from ISP. So how will be that case? So basically, all the organizations, like most of the organizations, have direct pairing with the most in exchanges, basically. So anyways, the route which we will receive from in our router from all the four links, like your 3 ISP links and 1 pairing links, pairing link, Nixie pairing link or exchange pairing link, we can say. So based on the ACE path, so the best path will always take from the pairing based on the ACE path reachability. Okay, or you can configure a route like configure a policy. You can map a policy where we can mention that the ACE number of Google will go from my pairing link only. So that can be done using the policy. So the ACE number of Google and ACE number of Amazon will travel from my pairing link only using that policy. So that will have the attribute which is configured in that policy for traversing that traffic, your Google and Amazon traffic, from the pairing link only rather than your other 3 ISP links. So you will also have routes in your routing table from other 3 ISPs as well, but that routes will be the secondary routes. The preferred route will be using your pairing link by tweaking the changes by applying the attributes. So is your question answered or any doubt? No. Thank you. So again, one just like example I want to give, like for example, like your question is like you have 3 ISP. So you have announced a pool. Pairing you will have to take from exchange only. On any exchange service provider, like Nixie is one of the exchange service provider. So you will have to take pairing from there only. No, your community value will travel across the route. Your community value will travel across the route to your from your upstream service provider to your destination route. So it is a like tag value for that route to identify the origin of the route, you can say. So if you do the IP lookup for subnet, if you do the BGP lookup for any of the subnet, in that you can see the community value as well, the tag value from the origin route. So it is a carrying attribute, basically, community value. Community value is like it is a numeric number, basically. So it doesn't matter your ACE number is like 16-bit ACE number or 32-bit ACE number. It doesn't matter. The one question is not been answered. Like if Nixie have more than, I will give you one scenario. Like if you have 3 ISP, for example, for your service provider, 3 service provider, and 4th is the pairing service provider.
Like we can give our example as here as well, because
yes,
we have multiple ISP as well as the Nixie pairing as well. So that would be the best example.
Right. I'm doing that. So basically, you have 3 service provider, for example, Tata, Vodafone, and Airtel, and other service provider is the Nixie. For example, you have taken the Nixie link, which is the exchange. So Nixie has a routing table which is preferred, apart from all these routing providers. Which is why it is preferred that Nixie is connected backend to the specific routes. So basically the exchanges give only a specific routing table, like the ISP gives the entire routing table, like 9 lakh internet routes. But the exchanges give only the routes which are directly connected or which are directly paired through them, basically. Okay. So the route limit is limited for exchanges. So always the route is been preferred from the exchange in that case. So if the eBGP protocol is used for importing and exporting all the routes, and suppose you have 3 ISPs and you have taken all the routing table from all the 3 ISPs and taken all the routing table from NIXI as well. But NIXI has a direct pairing for the specific routes for which always NIXI will be the preferred path, or exchanges will be the preferred path. So in your ACE path, suppose if you look in your router for the route that 1.1.1.1/24. So in that you can see 4 origins. So 4 origins with 3 ISP and 1 exchange. But you will also see the ACE path. So from NIXI for backend, the 1.1.1/24 route is directly connected. So always it will be preferred, unless and until you have not done any changes in your policy for these routes. So always the NIXI will be the preferred path in that case, as the ACE path is lowest, or the it is the best path to reach your destination. So is it clear, Mohammed? Please tell me about from Asharuddin. Please tell me about private IP advertisement and public IP advertisement in BGP. So basically, BGP does not look after the private and public. Okay. So only the thing is that the BGP table, your routing table, which is either your private, it is or public, it doesn't matter. So basically, only the thing is that when you have to advertise any of the routes for your external BGP pairing or your upstream service provider, in that case, you will have to enter one command that please drop my private IP advertisement for this pairing. Otherwise, your routing table will be same in your routing for private IP as well as public IP. Only at the time of advertisement for external BGP peering with outside your AS number, in that case, you will have to type that command that you will have to drop the private IP advertisement towards these external BGP peers. Otherwise, there is no difference, like nothing matter, like private IP advertisement and public IP advertisement in BGP. Like ISP does not understand the private IP address. It understands only public IP address. Like basically the policy is being configured on ISP side as well for importing, taking the routes from the AS number basically. So anyways, if you advertise the private IP address for that neighbor also, so it will be dropped in that case. If you don't have full routing table, then it will go via default route. So basically, if most of the organization takes only the default route instead of full routing table, like instead of giving the using the resource utilization of your router, instead of taking the full routing table, some of the organization take only the default route and they play only on the default route. But in the default route, the balancing is not possible. Basically, it will only one will be the preferred path in default route. Whereas if you take the entire routing table in your router, then you can tweak the changes as per the requirement, basically. But this private IP advertisement, you mean like that is the direct pair for your organization.
I think there seems to some issue with the Vinayak network. We'll wait for a few minutes to rejoin him again.
Is my screen visible?
Yes,
Yes,
Vinayak.
Yes.
So basically, like all the topics has been covered, and we will look about the best practices which are used for BGP. So basically, for reachability, never reachability, IGP protocol can be used in backbone network, and also like advertise only what you serve or take back from your upstream service provider as little as you can, and take the shortest path for exiting your traffic. So basically, like just want to share one thought. Like first of all, like first we have a big problem with routing table growth of the routing table in internet. So suppose if someone decides to deaggregate a network that is used to be a single/16 network, then they could potentially start advertising hundreds of new routes. So every router in the internet will get every new route when this happens, when the route is being deaggregated. So basically, from ISP or different service provider, so organizations are being pressured to like combine multiple route in a single advertisement. Suppose one of organization is advertising 10/24 routes, and if it is a way to aggregate the route, then we can aggregate the route. So if aggregation isn't possible, so especially if you want to break up a /16 route into two geographical separate routes, we can say, then currently the routing table has been approached to like nearly 9 lakh routes, and they are growing day by day. So this is the first concern for the routing level. So therefore, there is a pressure from multiple ISP to aggregate the route from the organization to downlink the multiple updates. So second, there is always a concern that someone will advertise the internet. So if some large ISPs customers suddenly decide to advertise everything, and the ISP accepts that route, for example, so all the internet traffic will be sent to the small customer base. So basically, there is a simple solution to this, which is called as the route filtering, which already we have discussed. So this is the best practice for implementing the BGP in internet. So it is quite simple to set up the route filters so that your routers won't accept route from customer that you aren't expecting. But many large ISP will still accept the equivalent of default, like from multiple pairings which you have done. So this is the second concern, and for mitigating that, we can use the route filtering. So finally is the flapping. The third concern is the flapping of the routes in BGP. So basically, BGP has a mechanism to hold down the routes that appear to be flappy. So if the route is been flapping continuously, there is a hold down timer in BGP. So route that flap or come and go frequently, usually not reliable enough to send the traffic. So if route flap frequently, the load on all the internet routers get gradually increased. So due to this, the processing also increase or updates also increase every time the route appears and disappears. So basically, there is a best practice called as the dampening of the route. So if the route is being continuously flapped, so dampening will prevent the BGP peers from listening all the routing updates from the flapping peers, we can say. So dampening is the way. So the amount of time, the hold down time, we can say, it increases exponentially with every flap in the dampening. So this is the use of the dampening feature in BGP. So basically, it is like it can be avoided for getting the updates for multiple routes. So these are the basically best practices which can be followed for implementing BGP in environment. And one major concern is like the challenge in BGP implementation, like challenge in security challenge in BGP. So one example is like in 2008 when the Pakistan government tried to ban the YouTube in Pakistan in some areas. So basically, it was communicated to the Pakistan Telecom. So Pakistan Telecom used BGP to route YouTube address blocks into black hole. Basically, that telecom used BGP to black hole that route. But accidentally, this routing information somehow got transmitted to the Pakistan Telecom upstream ISPs globally, which then propagated to rest of the world. So in that accident, so most of the YouTube traffic from across the world ended up in black holing in Pakistan. So this was the challenging BGP, like a single accident command can do whatever. So there are multiple policies which can be implemented, and there is a mandatory thing nowadays from the ISP as well for limiting the routes which they are taking. So using the route filtering. So basically, these are the best practices to implement BGP over the internet. So this was the last slide for our today's session. So if you have any questions, so please feel free to ask.
Vinayak, Praveen Kumar has asked one question. So do we have
Okay.
any on the route filtering?
Lab in the case can provide you, but currently we don't have any lab for route filtering. So you want scenario? That's a scenario based, like verbally I can tell you the scenario, like for within two AS number for sharing the routes between each other. Suppose I have local routing table, I have hundreds of route and I want only one route to be exposed. So that route can be exposed to the other AS number using route filtering. Same applies to the other AS also. This is the scenario. That route filtering can be applied using the policy, like import and export policy, basically. which we have already discussed. Yeah, definitely the presentation will be shared.
Yeah, as the Nixie officer said that the presentation will be available in a training.nixie.in, so we can view you there.
Yes. Okay, so if anybody don't have any questions, so I think we can conclude. Thanks.
Thanks, Paul, and thanks, Ashok, and thanks, Vinayak, for this wonderful session. And in future, will keep continue with others on other topics. Thank you, Ashok. Thank you, Vinayak, and thank you all participants.
Definitely. Thank you for this opportunity.
Thank you.
Thank you very much. Have a good day. Bye.
Thank you, everyone. Have a great day. Bye. Take care.
Thank you.
Thank you.